Well, welcome back everyone to our new season of Regcasts. Welcome to our new studio as well. We've got a big topic for you this time round, one of the biggest of all, internet performance. So that's something that involves quite a lot of moving parts, and so we've divided our Regcast today into at least 4 parts. We've got a couple of demos coming up later on that you won't want to miss. There's a whole bunch of detail in there that I'm guessing that you've never seen before. So as always on our Regcasts, make sure that you ask all the questions you want to ask. If you don't ask the questions and we don't tell you the things that you want to hear, well, it's your fault for not asking the questions. So make sure that you do it. Now, because it's our new format, we wanted to make sure that Tony and Dale were still involved. So we asked our old mates, Tony and Dale from Freeform Dynamics, what does internet performance really mean? And how do you measure it and how do you monitor it? Can you introduce us to it and tell us why it's important? Can you go away and make a video, we asked, and they did. And this is what they brought back to us. So if we could roll the video.
My name is Dale Vile.
My name's Tony Locke.
And today we're here to talk about managing internet performance, and we're going to be dealing with the question, can the internet be tamed? Now, we've all experienced dodgy internet connections in our personal lives, but what about when some aspect of your business is involved? Tony, why are we talking about this now?
Basically because the register readers have told us we've got lots of things going on. We have more and more external users, both inside the company and outside of the company. So on our real end customers, we've got the customers themselves. We've also got our partners and suppliers all accessing our internal systems. We've got more and more mobile users who are spread around all over the place, in country, out of country potentially as well. We have more and more people remote working, whether they're working from home or in branch offices. If you're a bigger business, you might have offices that are all interconnected. And more of the applications and services that we're using internally actually use cloud services themselves, whether directly or indirectly, maybe accessing some mapping applications, payment services, lots of things that are invisible to everybody, but it's all inherently dependent on the internet.
So a lot of internet dependency, and it sounds like it's easy to forget that it's internal as well as external comms, isn't it? And I guess we've got a lot of geographic distribution in the mix as well.
We have indeed. And it's becoming more and more distributed all the time.
So I guess the implication of all this is that the internet is becoming pretty business critical. Is that something you can expand on a bit?
Again, the register readers have told us on all of the surveys that we carry out with them and the conversations we have with them that poor internet performance essentially becomes reflected in at least 3 dimensions. Top of the list and most visible of all is in terms of potentially lost revenue and margin. We've got unhappy customers, and if our customers are unhappy with slow performance of our systems, then they take their business elsewhere. Also, increasingly now, as we're trying to do more and more digital business and transform our organizations in many ways, we have the whole network performance impacting there on potentially taking away the opportunities from new services. And then as we go on, there's a whole lost productivity, something that's, again, often invisible internally. But if employees can't work as efficiently because they're waiting for systems to respond, or we're waiting for information to come from the internet, from external services, that slows things down. And sometimes that even feeds back into the top line there where they're servicing customers if they're in a call center, so they can respond more slowly so they can do fewer transactions. Basically, it all comes down to lost opportunity, slower response times, and all of this really leads to unhappy people, whether they are your customers, your partners, your suppliers, or your staff, and that's never a good situation.
So pretty serious, not something we can ignore. Is this something that's just snuck up on us, though?
Absolutely. It's one of those things. Traditionally, in the data center of the readers out there, SLAs have been based on availability rather than performance. And to a large degree, even our internal networks are often not that well monitored and managed. We have a big knowledge gap here where we don't have the tools in place to monitor systems. We don't have often the operational processes to act on that knowledge. And perhaps most importantly of all, we really don't know, is it even possible to manage the internet?
Yeah, I've heard you talk about a few myths in this area.
Indeed. There are some great things there. The idea is that the internet simply can't be tamed. If we do try to manage things, it's complex, it's expensive to do, and really the only option that we have is chuck more bandwidth at it. That's the only thing we can do to actually improve performance, and that's clearly not the only answer in town today.
If we're going to do anything about it, though, I guess we need to understand some of the underlying causes of the issues, because that gives us a clue, I suppose, as to what we actually can do about it.
Absolutely. And again, the causes of slow service are many and varied. Some of them are to do with the inadequate or aging infrastructure, both in terms of the computer systems and storage systems that we have running internally, as well as potentially under-resourced external cloud services. But there's also the networking that interconnects all of those. There could then be other things that the network doesn't really have much effect on, and that's inefficient application coding. But the third-party services there that we pull in from outside, as I say, often completely invisible in these days where we're building more and more composite applications, that's quite invisible. And then there's lastly a couple of areas where we can have some dramatic impacts on performance of applications, and that's just the distance between people, because distance does matter with networks. So where are the users? Where are the applications? Where's the data? Where are these composite systems that are these services that we're pulling in from the internet located? Are we pulling in the most appropriate ones for our performance? Are we actually putting our data close to the users and the applications close to the users if we have that opportunity? And lastly, how do we actually manage all of that routing of traffic around these complex systems?
Okay, that's quite a lot there that can actually impact what's going on. If you wanted to start addressing that in a methodical way, where would you start?
Again, it's the usual three things that we have to do, and that's for the readers out there to understand, well, what exactly is it that we need to manage and to measure? What do we need to put in place to monitor things? What's important to us? What are the tools that are available to the readers to help them do something about it? And then the practical stuff. How do we do this? What's the good practice for us to put in place so that we can actually start to make things better for our users and for our businesses?
Tony, you make it sound so easy.
Absolutely not.
Well, terrific work. Great stuff, Tony. That was very good. Do you enjoy making that?
It took a lot of effort to get it into a format suitable for the Register audience that didn't involve Dale and I, shouting at each other and going off on wide divergent topics.
I think that means no, doesn't it? But thank you for doing it anyway. And so, having set up those questions, we now need to answer them. So we've got two guys who are very well qualified to answer them in the studio with us today. First of all, from Dine, Paul Hayward. Paul, welcome to our studio.
Thank you for having us.
Now, some people won't know what Dine is. Can you explain that?
Sure. Dine is a cloud-based internet performance provider. We help companies monitor, control, and optimize online infrastructure, and we have a specific focus on the DNS layer to use that for traffic management services.
I see. We've already got a question in here from Jeff, who says, for a typical company, aren't these issues largely beyond their control?
I feel a little bit spoiled to get that question because it kind of tees me up, doesn't it? I think that's the whole purpose of Dine. Steve will introduce himself as well, but we can go into it in detail. But the internet is an incredibly complex thing. It's complex in the way it's made up, and I think there is an assumption that it's just something we can't do anything about. What Dine does is it makes the internet visible for everyone. Allows you to see how it's performing and how you can utilize it. And from a DNS perspective, you can then manage where you're sending your customers to. So it's not about having an AS. It's not about having transit and peering relationships. You have so much power through just the ability to deploy cloud resource anywhere in the world very easily and very quickly.
And the good thing is we've got you're showing how to do this later on.
Yeah, we're going for a couple of demos. So it should all
don't spoil the surprise for everyone. I've seen them, they're good. And so also, I'd say you're from DevOps, guys, Steve.
It's all about the product placement.
It's all about the product placement. Now, I think let's have a look what we described you as, a master Uber geek, Steve. Is that fair?
I hope so. I've been doing this for 25 years, so I think I've got my geek credentials down pat.
So. You do this sort of thing every day, don't you?
Yeah, so DevOps guys, we're a provider of sort of managed IT operations and particularly DevOps automation. I also started the London Web Performance Meetup group 3 or 4 years ago. So I've been living and breathing in this space now for 3 or 4 years. Do
you actually have a meetup group for this?
We do.
How often do you meet?
Once a month. So it's just go to meetup.com and search for London Web Performance and come down and talk about performance and internet and all sorts of good things every month.
I'm busy that day, but No, that's a plug. You know, I'm happy to let you have on that because that's
Beer
great,
and
guys.
pizza at the end.
And there's beer and pizza.
Yeah. Now, for Samuel, you've put the question in to say, do we get a transcript at the end? We can't transcript this, I'm afraid, but what there is an on-demand version of this, so you'll be able to watch this all again. I would really recommend that because there's going to be a lot of information in the next 45 minutes, and so it will repay repeated viewings. I think that's fair to say, isn't it? So first of all, we need to establish why we are measuring internet performance, and Paul, this one's going to be for you, so let's have a look.
Okay, so let's strip it back to basics. When we think about internet performance, fundamentally we're talking about the delivery of content to end users faster, safer, more reliably than ever before across the internet. In terms of how we go about managing that process, we probably need to take a step back and say, okay, what is the internet? And it is a complex thing, and we shouldn't shy away from that. So it's one end-to-end internet is really about 50,000 autonomous system numbers, about 500,000 rooted IPv4 and IPv6 networks. I'm starting to intimidate people. And about 239 participating companies. And that's before we think about, countries, before we think about wireless, mobile, Internet of Things, all the things connected. So incredibly complex. So an internet performance provider needs to very simply and very easily and quickly provide insight into that in a very digestible manner. And then provide the tool set that allows you to actually affect change. We call that actionable intelligence. And again, that's what we're going to go into today.
So basically, you don't just tell people what's going wrong, you try and fix it for them?
We allow people to essentially interrogate the internet. So you can go at things with a business-led question. Okay, I'm an e-commerce company, and I want to go into Russia, I want to go into Asia, I want to go to the States. How do I do that? How do I utilize the internet as a means of logistics to take my story from A to B?
Okay, now let's have a look at the next. Steve, this one's yours, isn't it? And that's the sort of diagram that you deal with all the time.
Yeah, I mean, I think a lot of the people who are watching the webcast would have seen these kind of diagrams. Bog standard e-commerce infrastructure, architecture diagram. You've got two data centers and they're all kind of connected, and I've got layers of switches in my racks, and then layers of switches up, and then I've got routing layers, and then I've got IDS in there, and I've got edge firewalls, and all those sort of good stuff. And I think the key thing for us is that we look at that diagram. There's two key points. One is that the cloud is just this little tiny box, and it's seen as this ubiquitous thing. It's a cloud and it's a blob, and that's outside of my control.
It's like in the old maps where there's here be dragons.
Dragons, exactly. That's a really, really good analogy for it. And I think that's a lot of, I think that for a lot of us, I mean, I'll probably put myself included in many, so we go, I don't want to worry about that. But I think now we've started in a situation where we can start to play with that and manipulate that. I think the other key thing to make is that when we talk about internet performance, the work that Steve Souders did, and when he was back in Yahoo, writing some books on front-end engineering and even faster websites, was that only 20% of your application performance really happens in your back end, inside your data center, and 80% of it is in your communication back and forth between, say, a web browser in a standard e-commerce application.
It's the thing, Tony, that we don't really talk about very much, isn't it? That most of what we've done on these Regcasts, for example, and most of what we write about is only about a small portion of application performance.
It's essentially been focused in the data center, the bits that we have traditionally had good handle on.
Naturally, because we have control.
Yeah. That's where we've had the management tools, that's where we've had the people to actually do this. And that's where, until pretty recently, the internet's still comparatively new in terms of being widely used all the time by everybody. All the attention was there for good reasons, but now it's time to change.
It's interesting, the Alibaba CEO yesterday was on CNBC, and he was asking loads of questions, can you keep this growth? And he just went, the internet's really young. And I thought it was just a really poignant moment to say, this is still just the beginning of it.
We will still be around doing these Regcasts to try, but they'll just be very, very different subjects.
You just have even less hair.
All right. I can give it now. I don't say.
Here we go.
Well, we got Aussie's in today. Let's have a look now. This is one of the big internet myths, isn't it?
Yeah, I mean, if I had a penny for every time somebody sort of said, oh, it's okay, when we get a faster connection in, when we get this in, when we get that in, when we go from 2G to 3G to 4G, it was always going to be that bandwidth was going to solve the problem. Some great work was done by Mike Belshie at Google, back 5 years ago now. We basically showed that, above about 5 megabits per second, the benefits that you get from increasing the bandwidth for a standard e-commerce application just drop right off. Mm-hmm. So suddenly latency becomes the difference. So it's not the fatness of the pipe, it's the length of the pipe, if we're sort of using the sort of pipe analogy of bandwidth and latency. And I mean, if we take this example from back when I used to work for another company called Site Confidence, we did lots of monitoring around the world using a synthetic browser, very stable. This is polling the same application and the average speed from a London-based POP, Madrid, New York, San Francisco, Singapore thing. And we can see, in London, it's 5 seconds to load this page. And out in Madrid, it's 16 seconds. In Singapore, it's 12 seconds. That impact is largely just due to latency because you've got, average of about 120, 150 page objects now. Every one of those is incurring a round trip latency.
So it's going like this?
Back and forth, back and forth.
Uh-huh.
Traditionally, the way that browsers work, the browser vendors are doing a lot to try and improve that. We've got to talk about, we could talk about Speedy and HTTP2, which is coming out. All of these changes are how do we reduce the number of round trips the browser needs to make, and the reason we want to reduce the number of round trips the browser makes is because of latency.
Small differences get magnified in this
Exactly,
way, and even if we do fix it in the browser, there will be that long tail of legacy browsers, won't there? So we have to think about how people are using this stuff.
But the way all this stuff grew was not by design for long distance communications, and that's what really has to change now.
Change the speed of light at the end of
the speed of light is still an issue.
We're working on it.
Okay, but that's a different Regcast.
I think just on one point there, to real concrete example, we had one customer where the peering was bouncing back, and it was going via the US. Added 100 milliseconds latency, that equated to a 5-second increase in the page load time. So people look at it and go, well, it's only 100 milliseconds, but across a page, that became 5 seconds. Mm-hmm. So and that's the same page, one customer, due to a transit and peering issue,
And can we design on the page? I mean, like you say, we design on the page to reduce the number of back and forth, but that's going to be a lot to work, and we're going to reach a limit there where still latency is going to dominate.
Oh, absolutely.
Yeah, I think latency is the issue that you need to solve. So how you do content delivery and how you from a proximity perspective get your content and your data closer to the users that you're trying to serve.
Well, also, as you mentioned before, with mobile and single-page apps, we're becoming very much more of an API-driven world.
Yes.
And API is all about little, I want small calls, get some, take a call out, get some JSON data back, bang, bang, and I'm expecting that to be super fast. And if I'm 100 milliseconds away because I'm in some data center in another country, I'm not really fast.
So this really is, we claim a lot that we're having to design infrastructure for the technology world that we're building, but this really is the fundamental part of it, isn't it? This is the 4/5 of the world that we're building here. Yeah.
And it's the stuff that's currently pretty invisible, but becoming an issue for people.
Yeah. So let's see, you've got a stat here about the research about how actually this does affect. It's not just a technology problem.
Yeah, I mean, this stat's been around for a while, and anybody who's been to something like Velocity Conf has probably seen this one before. But I think the main message here is performance impacts money. Mm-hmm. There was a example of research Bing did where they artificially slowed a page down by 1 second and dropped 2.5% average revenue per user. I mean, this is for you're a search engine company like that. I mean, that's real money for real customers. A 7% drop in conversion rate for an e-commerce customer is massive. And that's a 1 second delay. And the good people are aiming for page loads under 3 seconds, and we'd see people all the time. 7, 8, 9, 10. 10 seconds to load a page. I mean.
And the even more important thing, I think, is that it's the customer dissatisfaction. The customer satisfaction score, because that's the point that really hits back, not just on the one transaction, but for the future going.
Yeah. I think the thing that also you need to remember is we so quickly go to e-commerce, we so quickly go to websites, but if you're thinking about video conferencing applications or HR portals or anything to support actual global workforce or remote users, there's a massive adoption problem, and that leaks into a big governance problem for businesses as well. So this is just as much about how businesses use the internet for their own corporate IT as it is about how an e-commerce company or a search engine might use the internet to reach end users.
But to be very clear on this, we're not just saying this is a terrible world, poor us. What we're saying is this is a problem to be managed. Management is possible to do, and you can, and so these statistics mean you can make the business case to do the management. Yeah.
And the likelihood is that you haven't even thought that this is something you can do about.
And that's the key point. I don't think people necessarily realize that the tools are available to have really simple visibility into these things.
Yeah, so for example, Tim, it's a question, surely I should be controlling traffic from my edge, not from within the cloud.
Yeah, I mean, we'll probably, I reckon once we do the demos a bit later, people will be like, oh, okay, so now I can actually ask questions of the internet, and I can now, instead of thinking about my edge, I can actually just think about the internet as an extension of my business network, and that's where we really want to get towards.
Okay, let's get those questions coming. There's good ones so far, Okay, so Paul, explain a little bit about this then.
Okay, cool. So this tends to be, when we talk to our customers at Dine, it used to be very much about, okay, what's your DNS resolution time? And okay, so you've got 2 data centers, let's load balance between the 2. But now it's become a conversation about the digital supply chain. And by that I mean organizations need to fundamentally think of the world and then think about their customer demographics. What are the key markets? What are the values of their markets? Who are they trying to reach? Then overlay what we would define the internet posture, which is your presence on the internet and what geography or what user groups that allows you to reach today in an acceptable manner. Again, that will make more sense in a bit. And then over the top of that, if you lay the one on top of the other, you have this heat map. And that essentially allows you to understand across your digital supply chain, where the gaps in your logistics are, essentially. Where are the people that you're not reaching and you need to reach them? And then apply technology to that problem. So then it's about deploying cloud resource in certain places using CDNs, maybe building your own data centers if that's the sort of organization you are. But there are lots of different options. But first, you need to always make sure that those options are focused on improving end user experience within your target customer demographic.
And I think also, if you take that heat map view of the world, I mean, you've got real user monitoring solutions now that really enable you to see, and you can deploy them for a cloud-enabled e-commerce application, or you can use them on your, as long as it's a web app, you can use it on your HR portal or your SharePoint portal that you've got for your company. And and they'll pull you up a graph and they'll tell you exactly what's the page load time for this person in this office in this location. And I mean, I've worked in large enterprises, and there's probably plenty of people on the webcast who worked in large enterprises, and there's that guy in the Singapore office, or there's that guy, in the Tokyo office, or wherever it may be, who's complaining that HR portal that's centrally located in the US is slow for him, and now you've got the tools that will tell you they are slow, and we can start to understand why they're slow.
It's something we've talked about in the past. People have measured service quality on metrics that are not really suited to the end user response time. And that's something you now can do something about, and you must do something about.
All right, let's have a look. Now let's have a look at some of the process of doing something about this. Now, because I don't necessarily associate DevOps with this.
Yeah. I think the short version is like everything in a DevOps philosophy. We're trying to think about the big picture. That's the first thing. The first way of DevOps is systems thinking and thinking holistically. But more importantly, we're trying to move everything back to the left, and we're trying to see how do we build these, what we used to call non-functional requirements. We like to call them operational requirements now, because non-functional is inherently negative. But I'm not going to get a high performance application if I hand the application over to the ops guys and say, right, now make it perform really, really well. I've got to think about performance all the way along, from when I'm planning and designing the application, when I'm coding it, I'm doing continuous integration testing, so I'm going to put some performance testing in there. I'm going to have my APM tools, AppDynamics, New Relic, stuff like that. I'm going to have them deployed in dev and test and prod all throughout the life chain and the life cycle of my application, the software development life cycle. And I'm going to be measuring it all the way along. So I can be optimizing performance all the way along the SDLC, not trying to sort of throw hardware at it at the last minute. And I can take the the information I'm getting from RUM, from my APM tools, from my Dine metrics about where my customers are in the world, and I can feed that back into my lifecycle. But whilst I've got this silo of dev and this silo of ops, there's no flow of information back. So devs are just keeping doing their thing based on what they think, what they've always done, what they think is right. Now we can give you real actionable metrics. DevOps, culture, automation, lean, measurement, metrics, and sharing. Share those metrics back, influence, all the way back through the life cycle.
Is it something you need to get specialists in from the outside to do, or is it easy to develop that kind of culture?
Clearly, I'm going to say you should get.
Should you hire someone like Steve?
Perhaps you should. But no, I mean, I think that you can certainly get started. I think if you try and do it with somebody from outside who's going to do it all for you, you're never going to get the cultural change. You've got to have the top end buy-in. I think that we can help accelerate that change for you, and we can point you in the right direction. But at the end of the day, it's like anything, you've got to want to change.
Yeah, well, we did a Regcast last year about DevOps culture, developing that, and it was very popular. It was very successful, but it also showed you how hard it is to do well.
Yeah. The other thing that's really coming out with the whole DevOps culture side is that it is about continuous improvement. Yeah. So actually measuring, monitoring, and changing where appropriate, but understanding what to change and the impact of the changes.
Yeah. Talking about measuring and monitoring things, what's this, Steve?
Yeah, so this is actually a little front end that we wrote that sits on top of. There's a really well-known testing tool called Web Page Test. So if you ever want to test how your application works, you can go and test it in multiple browsers, multiple locations around the world. But you had to test from one location. So we wrote a little geographical front end on it that enabled you to test from multi-locations. So this is really just showing you a web page. It's what'smyip.org, a very, very simple page, so we don't have banner ads and everything confusing it. And you can really just see that, in Miami, it's like, 2.7 seconds or something. And then suddenly I'm over in Wellington in New Zealand, and I can't actually read it from here. Six and a half, 6.2, whatever it is in Hong Kong. And this is a really, really simple web page. That difference is latency.
Yeah.
There's no other factor in there other than the fact that New Zealand's on the end of a really a long way away.
Yeah.
Sorry.
Good. Yeah. Whatever your emotion about New Zealand clouded your delivery of that, but you stopped yourself just in time, which is fine. But actually, just a simple tool like that makes a very important point if you're building a business case on the back of this, doesn't it?
Yeah. And if you go and look at Web Page Test, one of the other things to do is you can record a video and you can compare two websites. So if you ever want to make a business case for performance, record your website, compare it side by side with your main competitor website. As long as your competitor website's faster than yours, you'll get the money from your boss.
Lovely. Well, thanks very much for this, guys. Now, we need to. It's time to have a demo, isn't it? Let's have one of those. If you're watching this, stick around, because after the demo in a few minutes' time, we can answer any more of your questions that come in. We'll do that. We'll be talking about. We'll be introducing the second demo, which is a little bit more advanced. But this one, Paul, tell me, what is in this demo?
Yeah, so when we're thinking about internet performance and the ability for all organizations to make change, not just people that have their own AS and they can buy transit and they can make tiering ranges, but what about every organization that's trying to deliver content? So we chose to demo our managed DNS portal, and we're going to walk through how you can manipulate traffic flow very, very quickly. I think we set up a global solution in 6 minutes. Mm-hmm. So you'll see this is very easy.
You've done it before. Yeah.
It's not.
But seriously, this is the sort of thing that anyone can use.
Yeah, I mean, I think people think about buying F5 boxes.
He's a managing director.
If he can do it in 6 minutes, anyone can. Sorry, mate.
That's probably true. But yeah, let's take a look at it.
All right. Yes. So if we could run the demo now, and we'll be back in a few minutes.
Okay, so let's dive straight into Dine's managed DNS portal. I thought DNS would be a great example because it's really, really quick and easy to deploy from a traffic management perspective and as a tool to handle internet performance. And also, I don't think organizations truly appreciate some of the capabilities that DNS necessarily has. So we've used www.mycompany.co.uk as an example, and the first thing we're going to implement is an active failover solution. And then I'm going to take you on a little bit of a story of evolution of this company. So active failover is simply identifying when you have a failure in a data center or a cloud instance and diverting those customers, that traffic, to another site, whether that be a status page, whether that be another cloud instance. So we're going to now add this service. So we simply select active failover. We're going to add our primary IP address. And then we're going to add a secondary site. So like I said, this could be a status page or it could be another site. Then we're going to define our health monitoring characteristics. So essentially how you want the service to act. And then you would simply add that service, which is at the bottom of the page. And as soon as you've done that, that is then live. You have then got a DR solution. But now let's take this up another level. Let's think about if we now want to add a bit more complexity to the way we handle our traffic within region. We're going to add one of Dine's advanced features, which is called Traffic Director. So Traffic Director allows organizations to do things like equal load balancing, ratio load balancing, geographic load balancing, monitoring and failover, all within one service. And you can use as much or a little as you want. First thing we're going to do is look at ratio load balancing. So we're going to create a response pool. So within Europe, I'm going to define my IP addresses. I'm going to define my endpoints. So server 1. And server 2. And in the weightings, you can actually define that as like a percentage. So here we've done 4-to-1, which would be a 75%, 25% split in favor of the secondary IP address in this case. So now we're going to create a rule set. So this rule set is around the actual audience that you want to be treated in this way. We're going to add catch-all, all geographic regions, and we're going to go from there. So now we're at the point where we have, we have a fully implemented regional solution with how we want to do things. I'm just quickly defining my monitoring configuration. But now as an organization, okay, so you own your domestic market. You maybe take investment, you maybe have an ambitious CEO, and it's time to look outside your domestic market, and we're going to pick the US. So what we're going to do to enter into the US is we're going to roll out some infrastructure. Probably for ease of adoption, we're going to use a cloud environment. So we're going to use a CNAME instead of an IP address. We're going to add that CNAME in. I'm going to save that. So now that we have that response pool, let's define the rule set for the states. Now, from a geographic areas perspective, we have the ability, the granularity to do regions, countries. In the US, we can do states. In Canada, we can do provinces. You define those user groups, and we identify them automatically. And then you define the response pool, servers, cloud platform that you want to send them to. So we're doing primarily in the US, and then if that fails, then secondary will go to Europe, and so on and so forth if you have more. Okay, so now as an organization, you're a global company. You've had a lot of success in the US, and now you want to go and tackle the Asia Pacific region, and perhaps one of the most attractive markets today, which is China. So in terms of how you want to go after China from response pool, maybe you're not at the point where you have the operational capabilities or time zone capabilities to actually build out resource in that region. So let's use a CDN. So in the same way, we're going to use a CNAME. We're going to define that CDN, and now we're going to define the rule set for China. So what we're doing here is very simply identifying Chinese traffic by users coming in from that particular region based on their IP addresses. We're going to set the Chinese response pool, which is the CDN, as primary. We're going to do European data center as secondary, and we're going to US cloud provider as our third point of call. And that's now saved. So from this point, it's simply about publishing. And as soon as you publish those changes, they are live. And and there's no ordering of hardware, there's no lengthy configuration, there's no need for internal specialization around being able to do these things. And I think China is probably the best example, because it's such an attractive market, but there's a lot of intimidation towards, whether organizations can actually address it. Does it feel too foreign to organizations? Actually, we've very easily shown here that you can take your first step towards China by implementing a China-specific CDN and using Dine services to do that. Dine have helped numerous organizations in making that first step into China, and we've actually continually invested in the build out of our network within China as well, so we're able to handle DNS resolution within region.
Well, welcome back, guys. And there is one thing that I should have said to you before we went into that, which is there is a little tab, which some of you, I'm hoping, have found that for the second screen, if you want to make that the big screen, then you can do it. And we're hoping that if you did want to find that, then you did. And if you didn't, then remember, this will always be available on demand, and you might get more out of it watching this 2 or 3 times. I know that I did. I mean, I didn't get terrible amount out of it anyway, because but that's more about me than it is about the demo, which is terrific. I dug myself in there, but I think I got out.
You got out.
I think I got out of it. Okay, so
it's like an England cricket team.
Yeah, because it's a question coming in, and there's one question that always comes in to us: isn't this sort of thing just for the really big guys?
I think there are probably a number of angles for that. I think someone like Steve could probably talk about what you have to do within your application to be able to have a distributed network. But I'm going to go straight in where it would cost, because I think that's often one of the things people think about. Yeah, exactly. And I think people think of global server load balancing. They think of the major hardware vendors. They're thinking hundreds of thousands of dollars a year, specialist engineers to be able to configure these things, and lengthy installation times. I think we've dealt with installation time. I think 6 minutes, and maybe Tim could do it in maybe 9, 10. But from a cost perspective,
don't employ me to do it.
From a cost perspective, it's consumption based. So, but to give you an idea, for the average SMB business, you're looking at hundreds of dollars a month. You're not looking at tens of thousands of dollars a year. You're not looking at any upfront cost. It's all monthly recurring. And the other great thing is it matches the pricing models of the cloud market as well. So it's consumption based. It's based on how much traffic your site gets. It's depending on how big your bill is, essentially. So a big bill is often a good day for all of us.
Yeah.
But I think that's really important, because the other thing we see in the market with a lack of knowledge about the access to these tools is you have big cloud deployments, and then your managed service provider will then sell you an F5 box. Or they'll sell you a piece of hardware to stick in front of it, and then they'll go, yeah, I know you're paying for that as pay-as-you-go, but can you pay us £10,000 to buy this for you?
Absolutely.
And it's on a 3-year support thing, and you're going to have to get a new. So there's a big disconnect, and there are cloud-based services out there like ours, and there are others that can really allow you to.
You're not going to turn up on their doorstep and say, yeah, that was great, but if you really want to do some good stuff, you've got to buy all this thing that you can't afford.
Exactly. It is what it is. It's completely self-service.
Yeah, good. Now, you were also, Steve, you were also talking about, what's your McDonald's analogy on the...
Yeah, I mean, I think I actually have a friend of my wife who is a real estate agent who buys properties on behalf of McDonald's.
Yeah.
And we've talked about a lot about the kind of research they do into traffic patterns, demographics, footfall. What areas are up and coming. Where am I going to put my next McDonald's restaurant? And I think some of the things we're talking about here with Traffic Director and what we're going to come into talk about DII is that we now have the ability to work out, well, so if we take Amazon's got lots of regions worldwide. Which region should I put? First of all, should I go with Amazon, or should I go with Google, or should I go with Azure, or should I go with somebody else? And and then within those providers, which regions should I be using in order to get closest to my customers? I've done my market research. I've got all my data about where my real customers are from my my Google Analytics, or my I'm looking at performance data from my RUM. I know where my bad performance is, and I really like that idea. It comes back to, again, this digital supply chain. I'm taking some of this stuff from physical manufacturing, physical logistics, physical planning, and I'm applying it to what I'm doing. And I've now got access to the information to say, I'm not just going to guess I'm going to put it in US East or US West, or I'm going to start using the new Frankfurt data center. Just because I'm from Frankfurt, it might not be the best place for somebody who's, next door in Estonia or something, because they happen to transit via Dubai. You don't know. Now you can know. So I think people have got to think about how to plan this stuff.
It's all about getting that knowledge of what's going on. We touched on the digital supply chain in the introduction. It's really important. It's becoming more important because things are so interlinked. And if you don't have visibility, it's really hard to work out what's the best way to do anything.
Now, Tony, because you're on the non-commercial side, I'll put this question. What we had in the last demo there was a particular vendor's tool. We're now talking about Paul as if he's not in the room. But
Paul who?
How much of that, how much of that can you do without necessarily going into a particular vendor tool?
It's hard to do it without having some sort of solution. Yeah. Because otherwise, if you try and do this with just your standard network monitoring and management tools that you may have in place already, or you may not have much at all, it's really difficult to do. It's complex. It's going to take you a lot of time just to get the information, never mind analyse it and work out what it means.
And a lot more than hundreds of pounds a month.
And in your salary time alone, it's going to be visible.
Okay.
And never mind the fact that everybody's working 24/7 practically anyway. Just where are you going to fit the time in?
Well, this is a problem, and our jobs have grown up to take care of this sort of, to imagine that this sort of thing is unmanageable, and therefore our management time is already taken up. By our, I mean other people's management time. This is what the audience are telling us. So how much time should we be putting into managing the internet?
I think the way that the kind of modern IT manager has shifted over time is much more around that time spent previously on managing physical resources now spent on vendor management and supplier relationships, because it's simply the in-source outsource argument is like really prolific in certain areas. Data centers is a great one. You simply cannot replicate a purpose-built data center in an office. From power supply alone, I think everyone accepts that. And if we think about something as basic in people's minds as a DNS network, you cannot replicate a globally distributed DNS platform with the sort of resolution times that we would achieve globally and our competitors achieve globally by doing it yourself. And why would you anyway? There's really no benefit.
I think for me it also just comes back, obviously I'm going to bring it back to DevOps, but time, it seems to me to be an operations question. How much operational time am I going to spend monitoring? I'm saying, how much time are you going to spend in the planning phase, way back in your life cycle, to work out where am I going to put my data centers, what zones regions am I going to use, what zones am I going to use, what CDNs am I going to, what part of my application am I going to offload to CDNs? I mean, it on a day-to-day basis, not very much. Planning, quite a lot.
Yeah. It's really interesting. About 18 months ago, we did a survey with the Register audience asking about, the future of the data center. And one of the questions we asked there right up front was, how do you see things evolving over time? And, a huge proportion of the folks out there told us that we see us move more towards a service delivery type management approach rather than an infrastructure management approach.
To be fair, that's the ideal, and that's
the ideal. But before you can start moving down there, you've got to know, well, how are we actually performing now to even do the planning? Because if you don't know what's happening at the moment, then making plans for the future, you've got to see, well, where are the areas that maybe pay attention to first, because you can't do everything at once.
And I think one of the challenges is there are now so many variables, and that list of variables is ever increasing.
Yep.
So the evolution of planning is going to be automation. It's going to be how suppliers, even like a Dine, become a platform that you connect to, and there is a decision-making engine that sits within that simply delivers internet performance. You can set the parameters. Maybe there'll be performance parameters, maybe there'll be commercial parameters, but you define that, and then the decision-making engine essentially just does it.
So rather, as we become out of the service level agreements, produced a certain amount of you could specify some kind of performance, but it's not particularly useful to find out what you're delivering to your internal client or your external customer. And so you're saying, then take the business case, take those sort of business rules. These are our priorities.
Yeah, apply those. And what? I think actually now would be quite a good time to go into the demo, because I think when you think about what we've just seen from a DNS perspective and the power of that layer as a control plane of the internet, which is very agnostic, it doesn't care what the endpoint is. Now we'll go into looking at how we can interrogate the data and actually the richness of the data we can get around internet performance. And I imagine that your audience will put, 1 + 1 together and get 2, and understand that the automation of those two things together is probably maybe something Dine are working on behind the scenes. And I think that
teaser trailer.
Teaser trailer.
I don't know what they're doing behind the scenes. You hardly dare ask. But but they will now because you've told them to. But that's the thing, because we concentrate a lot on diagnosing the problem,
Yes.
and so this demo, as I understand it, is really about how you optimize. You begin to optimize.
It's about the ability to plan something, and anything you plan, you should be able to monitor. But really, our world is becoming so complex. The digital supply chain is so varied and so vast that the reality is we can't keep up with it. So we need to create automation. And actually, a lot of DevOps is about automation as well. And pushing all that together and creating platforms, and it all being about business-based outcomes, all being about criteria that you define as an organization, that's really when this is going to get really interesting.
Okay, well, in that case, the best thing to do is, rather than talk about what's in the demo, is actually show people, show the demo. So if we have our second demo, then this is the best time to show it now.
And remember to go full screen.
And remember to go full screen, yes. Thank you.
Okay, let's dive straight into the demo. So what you're seeing here is Dine's Internet Intelligence tool. This tool allows our customers to interrogate the internet, essentially, and it is the physical representation or the visual representation of Dine's data set. Let's dive straight in and look at an organization like Barclays. So, huge organization, tremendous ability to invest, and a great deal of maturity in the way they use technology. On the left-hand side, we're seeing their prefixes, their IP addresses, spaces, and how they name those. We're also seeing their physical representation online in the form of their AS numbers. An organization of this size and scale will own their own, portion of the internet. On the right-hand side, we're seeing their different domains, showing a lot of maturity from a marketing perspective as they focus their efforts on customers in global regions such as, Spain, we see France, we see Portugal, and obviously see the UK. But now let's look at an organisation that's perhaps more achievable, more local to us. It's not because I'm hungry, but I've picked Harvester because I think it's a lot of the time these demos are focused very much on high-tech companies. So it's very easy for me to use an Uber or a Pinterest, but it's not necessarily that relevant to kind of 95% of us. We saw that Harvester had one physical location, which was with Rackspace in London. The domains they have are on the right-hand side, but let's drill into that IP address. So what we're now going to see is how Harvester are connected to the internet via Rackspace. We see level 3, T-Listener, AboveNet. These are the providers that Rackspace are buying transit from to connect to the global internet. But now let's check that connectivity. What we're doing here is we're running live trace routes from a subset of our global sensory grid network. In its totality, that sensor grid network looks like 160 global vantage points that make up this proprietary grid. These are running continuous trace routes to fixed locations across the internet, and cumulatively we're processing around 6 billion data points every day. We're also ingesting BGP routing tables from over 500 active BGP sessions from over 300 networks. This is really what gives Dine a level of confidence in our ability to say that we see the internet better than anyone else. Here's another great representation of that in the fact that not only will we be able to interrogate the internet from a performance perspective in a minute, but here we're seeing all the physical hops involved in customers or the internet reaching that particular IP address for different parts of the world. We're also seeing from the color palette the dependency that Harvester and indeed Rackspace have on different networks to reach their global audience. If we now look at latency, this is showing us the actual internet performance across the globe from a latency perspective. We're seeing a really strong presence in Europe, as we'd expect, and it really dropping off as we go into Asia very, very drastically, and into North America, which we know we have strong links with. As you go from east to west, you're seeing performance drop again. So let's look into that performance a little bit more. Okay, so we're going to stay on Rackspace in London because I just think it's a relevant relevant provider, and obviously this is where we're doing this webinar from today. We see a really, really strong density of performance across Europe, again dropping off significantly in Asia, and also we're kind of reaching the east coast of the States, but really tailing off. So if we look at Los Angeles, for example, we look at 140 milliseconds to reach there. If we then go down to Dubai, 137 milliseconds. And then if we look at Hong Kong, you're looking at over 260 milliseconds. So we're starting to understand that if you want to have enter marketplaces or support remote offices around the world, the core applications and websites just simply cannot be hosted purely in London. So now if we want to look at performance specifically, let's say we look at 100 milliseconds, we can see that these are the markets we can reach, but we've also got to remember this is purely the internet. This doesn't include any application load or application delivery. So let's halve that down to 50 milliseconds, and we're starting to see that, whilst we have got Europe covered really, really well, the ability to serve outside of that to a decent level of customer experience is relatively non-existent. Okay, so now let's look at how we would handle Asia Pacific. Singapore is a great example. I've just selected software. The reason I've looked at Singapore is from an operational perspective. It tends to be where a lot of Western companies tend to land. Great talent pool, a lot of English speaking, so really an easy place to do business. But now let's look within Asia Pacific at a couple of different markets. Let's look at Hong Kong, for example. Okay, so we're serving Hong Kong in 37 milliseconds, which is great compared to the original performance from London. Now, if we look over at Sydney, 144 milliseconds, which is increasing. Asia Pacific's a big place, and Australia is a big place. But now let's look at Mumbai. And I always like looking at Mumbai because I think it's a great example of both a really strong market for e-commerce solutions or software solutions, but also where a lot of organizations have outsourced development teams or offshored, and therefore the teams in these offices in Mumbai, in this case, will need to have access to the back-end applications and infrastructure supporting the data center in Singapore. So of that 71 milliseconds, let's now look in a little bit more detail of what that's made up of. This is giving another great example of the depth of our data set and the level of insight that users can have into the internet. We're seeing a number of different providers that would serve between Singapore and Mumbai. Tata is the green one, and you can see that towards the end of April, Tata had some regional issues which saw a huge spike up to around 300 milliseconds. So customers Tata would have experienced that across this link during that period. So it's great for allowing people to both troubleshoot and also allowing people to make vendor decisions when looking at new markets and selecting providers. We can still even go a level deeper than that, and we can start to understand the different paths across the internet that Tata will take between Singapore and Mumbai. I think this is a great example of how the internet isn't a fixed asset. There isn't one specific journey between two places. Even with this specific example, we're seeing multiple different paths, and each of these paths will carry different performance characteristics, and also often travel through different territories and countries, which I know a lot of organizations are interested in from an internet governance perspective. So the other thing that's worth noting, and we've included in this tool, is the ability for organizations to create what we call a watch list. So if you have offices in certain cities over a certain path, or you have really strong customer markets, you can watch these and you can then go into your portfolio and then take a look at these and have this as like an internet performance dashboard. We can see, for example, at Frankfurt to Hong Kong, which is a path we're monitoring towards the bottom end of the list. Over the last 24 hours, we've seen a 62 millisecond change in performance. Which is just something that's really interesting for people to look at when they're troubleshooting, because organizations can spend a lot of time diving into applications to see if there are issues there or their hosting provider, when actually it could be changes in the global internet that are causing issues. So really, today was focused on advanced tooling around internet performance, and I hope that people have got a bit of a taste for the capabilities of the data set in terms of actually what questions you want to ask of it. That's really specific to organizations. Other great use cases of this tool are obviously troubleshooting around performance, but also we're seeing greater and greater demand for the ability of our data set to monitor malicious activity online, hijacking, but also change validation where new data centers or new cloud environments are brought online, and we want to see if the internet is actually registering that change.
And that's all we've got time for today. So thank you to Paul, to Master Uber Geek DevOps Steve, and also Dr. Stats for all their help today in the studio. Now, what have I got to tell you before we wrap up? Survey, that's what I've got to tell you. You will see that a survey's popped up. It will take you 30 seconds to fill in, but just tell us what you think, because at the Reg, we do more of what you like and less of what you don't like. So let us know what that is. What else do I have to tell you? Well, all of this is going to be available on demand. As I say, we'll break it up into sections. So if you want to have a look at the demos again, for example, or if you just want to hear us talk, or if you just want to hear Tony's analysis from the beginning, you choose. The final thing I need to tell you about is we have some more Regcasts coming up pretty soon, and we'd like to see you on those, see you as audience on those as well. So tomorrow, that's June the 12th, we've got Trend Micro coming into the studio, and they're going to be discussing Windows Server 2003 end of life. The title says don't panic. However, you might be panicking slightly if you've discovered Windows 2003. You have a security vulnerability coming up. They'll be telling you how to make sure that that doesn't have too much of an impact on your business. Please come along for that one. And also next week on June the 18th, Proofpoint is coming to talk about advanced threats and human factor. Yes, those users, they can be your biggest security weakness. They can also be your first and last line of defense. They're going to be telling us how to manage your users when it comes to security. Please sign up for that. They're all free. If you want to see some other Regcasts, please let us know what they are and we'll try and get them organized for you. Meanwhile, thank you for being with us for the last hour. My name's been Tim Phillips, and from the Register, goodbye.